Hey, Algebra 2. In this video, we're going to be talking about the properties of exponents. And this is 5.2, which also does radicals, but today I think we're just going to focus on exponents. So you learned these back in Algebra 1. Let's see if you remember. And the nice thing about the properties of exponents is you can always figure it out. So, for example, if I have like x cubed times x squared, right? This is the same as x cubed is x times x times x. X squared is x times x. So now we have a total of 1, 2, 3, 4, 5 x's. So this is x to the fifth. So what the rule is if you have x to the m times x to the n, if the bases are the same, that is the same as x to the m plus n. So you can add the exponents. So that's the rule. So same base. Same base and multiplying. Okay. If we have x cubed divided by x squared, right, we could rewrite this as x times x times x divided by x times x. Because we're multiplying and dividing by the same things, these will cancel, and I'm left with x. So what the rule is for this one is if you have x to the m divided by x to the n, you can just subtract, right? 3 minus 2 is 1. And again, they have the same base. Okay, what if you're multiplying? So if we have x cubed squared, okay, so we could think of this as x times x times x, right? Because that's x cubed, so in parentheses, x times x times x. But it's squared, so we have two of them, times x times x times x, which is equal to 1, 2, 3, 4, 5, 6, x to the 6th. So if you have x to the m to the nth power, you can multiply them. So it's mn. Okay, next one is what if you had two different bases? So if you had xy to the second power, so that would be the same as x times y times x times y, right? Because it's squared. So then x times x would be x squared, and y times y is y squared. So essentially what this means is you're going to multiply whatever the exponent was inside by that number. So if you have x, y to the m, it's going to equal x to the m times y to the m. Sorry, for some reason my throat, it's a little scratchy. Okay. We got two more. So I guess I could kind of in a way say three more. So one is if I have a negative exponent, so if we have x to the negative second. So if you have a negative exponent, that's equivalent to having 1 over it squared. So the reciprocal will make it positive. And the reason for that is because, where should I put it? I guess I'll just put it over here. It's because of the subtraction property that we had. So let's pretend that you had like x to the fifth over x cubed, right? I mean, sorry, cubed in the numerator, fifth in the denominator, right? You could think of this, right? X times x times x over x times x times x times x times x. So you're left with 1 over x squared. But if we use the subtraction property, right, it'd be 3 minus 5, which is negative 2. So this is equivalent to this. So then if you have 1 over x to the negative second, if it's negative in the denominator, then the reciprocal will make it positive. So this is x squared. So the rule is x to the negative m is equal to 1 over x to the m. And 1 over x to the negative m. So if it's negative in the denominator, you can just move it to the numerator. Okay, and then the last one is x to the 0. And x to the 0 is always equal to 1, not 0. And the reason for this is kind of like this, if we were to do division. So if we had like x cubed over x cubed, right? 3 minus 3 is 0. So this is the same as x to the 0. But if we were to expand it out, this is x times x times x over x times x times x. And this and this and this all cancel. But when they cancel, they're not just like 0, right? X divided by x is 1. Right? Anything divided by itself is 1. So the rule is x to the 0 equals 1. No matter what. I'll do an example. Do one example maybe too. So if I had an example like simplify let's do 10 in parentheses x squared divided by 6x to the 5th, and all of that cubed. So there's a bunch of different ways you can do this. It kind of is a mix of the properties and order of operations. I always recommend simplify what's in here first, because if we use the power property, right, that's going to make these things bigger. So make everything small first. So that being said, to make this smaller, right, I can reduce 10 over 6. These are both divisible by 2. So this will become 5 thirds. And then we could subtract our x's because we are dividing. So it's 2 minus 5, that's negative 3. Okay. Now I can use my power property. Now be careful because it applies to each term. So we have 5 cubed, and then negative 3 times 3 be negative 9. 3 cubed in the denominator. So my final answer, 5 cubed, is 125. We don't like negative exponents, so we need to move this to the denominator to make it positive. 3 cubed is 27, so this is 27x to the 9th. We're done. And I would like you to show like each property that you use. One more example. We'll do more practice in class. Let's do just like a multiplying one, I guess. So if you have one like 2x to the 5th to the 3rd times 3x squared. So you have to take care of the exponent first. You can't just multiply these together. So the first thing we're going to do is 2 cubed. And then here we can multiply it, right? So 5 times 3, because that's what the property says above. It's 15. And we have times 3 squared. And 2 times 2 is 4. So now I can multiply. I'm going to actually simplify a little bit first, which you could have gone straight to, but so 2 cubed is 8, so this is 8x to the 15th times 9x to the 4th. And 8 times 9 is going to be 72. And x to the 15th times x to the 4th, because they have the same base and we're multiplying, we can add the exponents. So 15 plus 4 is 19. So those are just a couple examples of using the properties of exponents, but there are so many different kinds of problems that you can do here.